Now, in the short run, firms make decisions primarily about how many workers to hire, since they can't easily change the amount of capital they use, things like the size of the building or the equipment that they have. Those are fixed for the short run because that's how we define the short run. But in the long run, firms have more flexibility. They can adjust both labor and capital to find the most efficient way to produce goods and to maximize profits. This means firms now face a more complex decision in the long term. It's not just about hiring workers at a given wage. They have to consider how much capital to invest in, so things like machinery or technology that makes workers more productive. Firms need to figure out the best combination of workers and capital that allows them to produce their goods at the lowest possible cost while meeting demand. To help us understand how firms make these decisions, we use something called isoquant curves. These curves show the different combinations of labor and capital that produce the same level of output. For example, a pizza shop might be able to make 100 pizzas in a day by hiring more workers and using less equipment, or by investing in better ovens and hiring fewer workers. Both of those can result in them making 100 pizzas a day. So the isoquant curve helps us see all the different combinations of capital and labor that firms can use to produce the same amount of pizza, or any product. So an isoquant, which is a terrible name, if I'm being honest, if we want to understand this, shows the combination of labor and capital that produce the same level of output. So in this example, we have two inputs in the firm's production function, labor and capital. Now this should look and sound a little bit familiar. Isoquants are to firms what indifference curves are to individuals. So along an isoquant, let's look at Q0 here. At each point or each combination of employment and capital, firms can produce the same level of output. The only thing is how much labor do they want to put in versus how much capital they want to put in. So if a firm wants to produce 1,000 units of a product, they can choose to use a lot of capital and a small number of workers, somewhere up here, or they could choose to use a lot of workers and a small amount of capital, which would be down here. An example is fast food restaurants. As wages rise, or say minimum wage laws rise, some of them are opting to go to self-serve kiosks in order to take orders. This is an example of firms choosing to use more capital and fewer workers. But then in your rural, lower wage areas, fast food restaurants like McDonald's tend to have more workers and less self-serve options. Either of these combinations can be used to achieve the same level of output, but they end up being different for the firm itself. Again, more capital or relying on more labor. The isoquant Q0 is the initial curve, which represents one level of output. So we could say that's, say, 1,000 units of output. Moving to isoquant Q1 would be increasing the level of output because it's farther away from the origin. So maybe instead of 1,000, it's 2,000 units. If an isoquant is further in on the graph, closer to the origin, so say if it would be down here from Q0, that represents a lower level of output. So for example, Q0 might represent producing 50 pizzas per day for your pizza shop. An isoquant further away, like Q1, might represent producing 100 pizzas per day. And the further an isoquant is from the origin, the more output it represents. But if a firm moves to a higher isoquant, that means that they become more productive. Either they're using more inputs, so more workers or more capital, or by finding a more efficient combination of inputs. Now, isoquants have four familiar properties, which are just like indifference curves. They're downward sloping, they don't intersect. Higher isoquants are associated with higher levels of output, and they're convex to the origin. These are just like the characteristics of indifference.